My name's Harsha, sir.
Saharsha. Okay.
So we are going to start sharp at 6 o'clock.
Sharp at 6 o'clock. Another 1 minute.
Yes, sir.
Okay. I thought I'll prepare something, but doesn't matter. We will start now. Who are the people now? Students. Most of the people are students.
Yes, sir.
From which
Uh,
colleges?
Many colleges, sir. Sir, should I start the session?
Right. I have to share, right?
Let me start the session, sir. Then you can share your screen.
All right. All right. Take care. You can
Hello,
start.
welcome. Yes, sir. Hello, welcome everyone. Namaste. I am Vardhaneni Saharsha, student coordinator at KIYE Foundation, and I'm glad to be a host for today's session. It is wonderful to see many of you here today. Please drop your name and college in the chat and let us know where you're joining from. Thank you all for being here. Let us start this exciting session together. Before we start, let me tell you a little about KIYE Foundation. KIYE Foundation, or Kalam's Institute of Youth Excellence, is a youth-focused organization in India dedicated to inspire learning, empowering young minds, and promoting scientific and science-related education in alignment with Dr. APJ Abdul Kalam's vision. It is a knowledge driven and industry platform that connects students directly with leading experts and professionals from the world of space technology, semiconductors, artificial intelligence, aerospace, and advanced engineering. KIY's mission is to bring the real world into your learning journey through expert led sessions, mentorship, and along with industry exposure. It is a youth transforming mission working towards Dr. APJ Abdul Kalam's vision to make India a self-reliant country, mentoring by Dr. G. Satish Reddy Sir, former Chairman DRDO and President Aeronautical Society of India. The S in STOCK stands for Space, Aerospace and Futuristic Technologies. STOCKS is a year-long online lecture series featuring 52 lectures, 52 speakers, 52 topics, and 52 hours of knowledge and inspiration. It is a movement to build the next generation of scientists, engineers, innovators, and leaders. Participants get to learn from top experts, explore career opportunities in space and defense, build critical thinking skills, and earn certification through active participation. The theme for today's session is Fascinating World of Aviation, Rockets, and Missiles. Before we move further, let us know more about KIYE through video presentation. I request one of the student coordinator to please play the video. Wow, that was a glimpse of KIYE, a platform where younger minds are guided, inspired, and given the right direction to dream bigger and aim higher. Now, to know about KIYE Foundation through a student's perspective, I would like to invite one of our dedicated student coordinator to address their experience. Please welcome Ms. Satvika. Ms. Satvika, over to you.
Good evening, respected dignitaries, mentors, and young leaders. I am Satvika, one of the active student coordinator of Kalam's Institute of Youth Excellence, and I am delighted to share my journey with Kalam's Institute of Youth Excellence. My journey with KIYE was begun in 2025 when I joined as a coordinator for Kalam Space Convention. It was a wonderful opportunity that introduced me to the world of leadership, teamwork, and event management. Working closely with students, coordinators, and mentors helped me build confidence and develop a sense of responsibility. Another significant milestone in my journey was being a part of executive team for Vigyan Vaibhav 2K26. This experience greatly enhanced my leadership and communication skills. It taught me how to interact with different people, convince them effectively, and work collaboratively to achieve common goals. Every challenge I faced became a valuable learning experience that helped me grow both personally and professionally. As my work and dedication were noticed, I was given an incredible opportunity to pursue an internship at NRSC Jirmetla, where I am currently gaining valuable exposure and practical knowledge. I sincerely believe that guidance, opportunities, and encouragement provided by KIYE played a major role in helping me achieve this milestone. Today, as I stand here as a part of STOCKS, I feel that my journey is moving in a positive direction. Every step has added new learning, confidence, and experience to my life. KIY has not only provided me with opportunities but has also helped shape my personality, strengthen my confidence, and inspire me to aim higher. I'd like to express my heartfelt gratitude to all the mentors and leaders who have guided me throughout this journey. A special thanks to our mentor Dr. G. Satish Reddy sir for his constant support and encouragement. Also, I sincerely thanks to Naresh Indian sir for his constant encouragement and belief in young people have motivated many of us to dream big and work hard to achieve our goals. My journey with KIYE continues to inspire me every day and I look forward to learn, grow and contribute even more in the future. Thank you everyone. Jai Hind.
Thank you, Satika. That was honest and powerful. If their words connect with you, do show your appreciation in the comments. Now, for the most excited event, it is my privilege to introduce our distinguished guest speaker for today's session. We are honored to welcome Dr. Rakesh Kumar Sharma, sir, former director at DRDO. Dr. Sharma is an aerospace engineer with over 42 years of experience in missile systems and hypersonic technologies. He is former outstanding scientist at DRDO and associated with Defense Research and Development Organization for decades. He holds BE in Aeronautical Engineering from Punjab Engineering College and ME and PhD from Indian Institute of Science. He was the project director of the prestigious Hypersonic Technology Demonstrator Vehicle program and has represented India at international conferences in USA, Australia, Japan, Russia, Singapore, and Israel. Mr. Sharma is an author of 5 books and presenter of 35 research papers and also achieved one of the prestigious Dr. Biren Roy Trust Award and DRDO Technology Group Award. He currently serves as professor at Defense Technologies and adjunct professor at Chaitanya Bharati Institute of Technology while continuing to contribute to DRDO as a principal investigator. He has played a key role in India's missile programs, including Agni Missile Program and Astra Air-to-Air Missile. Friends, now we welcome Dr. Ramakumar Sharma, sir. Welcome, sir. I request everyone to drop a quick welcome, sir, in the chat box. Sir, thank you for taking the time to be with us today. It is truly an honor to have you with us. We are eager to learn from your experience and insights. With no further delay, I would like to hand over the session over to you. We are here to learn, to listen, and to be inspired. Over to you, sir.
All right. Thank you, Sunisha. Let me share first my screen and uh, please let me know, is it visible?
Yes, sir. It is visible. It is
All right.
visible, sir.
All right. All right. I'll just put it full side. First of all, thanks to Mr. Naresh and for inviting me for this lecture and Dr. Y. Srinivas Rao for suggesting me to deliver this lecture. All right. So the topic I have chosen is very generic, the fascinating world of aviation aerospace, rockets, and missiles. We will discuss right from the origin, the historical aspects, present, and future aspects. All right, let us start. Okay.
Yes, sir.
Before that, I ask question: what was the inspiration to the man that led to the invention of so many flight vehicles, aviation and aerospace? The man took an inspiration from the flying birds. He was mesmerized. He was perplexed. How these birds can fly? Why I can't fly? Okay, so he continuously started thinking the method, the means, how they can fly. So birds has got special things. Its own wing design, hollow bones, large lungs, strong muscles, which makes it to fly. And the principles are very similar as that of an aircraft. There's a beautiful book by Professor Satish Dhawan, former chairman of ISRO and director of Indian Institute of Science, Bangalore. I used to interact a lot with him while I was a student at Bangalore and he was the director. So this book one can go through. The timeline, I'll go a little fast and please tell me, give me, remind me to close it, okay? Before 5 minutes, I'll try to close.
Yes, sir. Yes, sir.
So the history starts right from mythology, early attempts, unpowered flight, then Wright brothers who revolutionized World War, which led to the rapid development of flight systems, World War One and World War Two. Then came air travel, jet space, and today onwards we are talking about of hypersonic technologies and all futuristic vehicles. Mythological evidence. Can you suggest me any vehicle in Indian mythology? Someone can speak?
Yes, sir.
Tell me.
Can you repeat, sir?
Any vehicle mentioned in Indian mythology? Flight vehicle.
No,
Name
sir.
of an aircraft.
No, sir.
You do, read Ramayana. Pushpak, have you heard Pushpak Vimana?
Yes,
Lord
sir.
Rama came.
Yeah.
Yeah, right? So, see, something mentioned, historical aspects are very, very important. All right, whenever I teach something, I first give more emphasis on historical aspects. We should be very curious. We should really know what has gone behind it. All right, so Vimana, Indian mythology, these are all pictures. They are all, they are on that walls. So Vedas, Mahabharata, Ramayana, Jain test, and Vaimanika Shastra is a very famous book, Vaimanika Shastra by Bhadwaj Rishi, which mention about secrets of Indian flying machines. One can go through. Rukma Vimana is mentioned in that, and also Shakun Vimana. They are all mentioned in the ancient history. And I'm surprised, you will be surprised that University of California, those people they have replicated this model and tested in the wind tunnel model in University of California, similar machine as done by the Indian heritage. You see how much they have interest in our Indian mythology. Then there's a Greek mythology. I'm sure all of you know this very famous story of Daedalus and his son Icarus. I'm sure all of you know. They were imprisoned, and this person used the wings and wax and made the wings and told his son not to go very high. And they escaped from the prison. But the son was very enjoying the flight. He started flying high, 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 and because of the sun heat, his wax got melted and he fell down. So this is a very famous story. Another Pegasus is a very famous mythological winged horse. All this gives an idea that people desire, man's desire to fly, exemplifies man's desire to fly. The first form of man-made aircraft was a kite. It was developed by Chinese. It's written in the 1635 book Mysteries of Nature and Art. This was the first man-made aircraft. Kite is an aircraft. Okay, this question is often asked. Is kite an aircraft? Answer is yes. Early flying machines. Let us come to now. Ancient dreamers. Very famous person, Leonardo da Vinci. Anyone has heard his name? He made a very famous
Yes, sir.
painting.
Yeah. The Da Vinci painting.
What's the name of the painting? Very
The
famous
Da
painting.
Vinci.
Very, very famous painting world over, Leonardo da Vinci. He was an engineer, scientist, inventor, painter, and a sculptor. Mona Lisa, I'm sure all of you will be knowing it. All right. So he gave the concept of ornithopters. Ornithopter means flapping wings and hang glider. Long, long ago, till next 300 years, nothing was made. Further. Then after 300 years, lighter than air concepts came. We know hot air balloon and airship. All right. So hot air balloon, Montgolfier brothers. They were credited with the development of first successfully piloted hot air balloon. Montgolfier and these two his brother. And very interesting story. They were having some big paper, not balloon, paper type of envelope, and by accidentally they put it over and heat this thing, and they found so much of force as if they're going to fly. This gave an idea, and then they made a big paper balloon. They found out yes, it is possible to get a lift. These are all by buoyancy. See, there are two types of aircraft: lighter than air and heavier than air. So right now we are talking about lighter than air, where the lift is produced because of buoyancy action. All right, we will discuss this. So hot air balloon, the first ever passenger to fly were a sheep, a duck, and a rooster. They had flown in a balloon in 1783, and this much a large crowd gathered in France. And the king wanted, actually, there's a big story. A king wanted a convicted person to fly, but then the inventor they requested. This is after this because these were the first flight, and then the second flight. This flight, king wanted a convicted person to be sent, thinking that nobody will survive this operation. But these inventor, they said they themselves will go. So these were the two people who were the first human passengers ever to fly, 1783. And the sad story is that many of the people, pioneers who have helped in flying, some of them has died in air crashes. This person also, I think this person also died in one of the flight. We will discuss. So today we know all modern ballooning. These are all used for joyrides. Okay, there are adventures and there are also dangers. Then came airship. This is the airship. Just see the people, so curious people watching all these things. Chaplin was a very famous person. Under his name, there's an airship. Different types of airships are there. Dirigible balloon, 1852. Okay. Then this is the passenger airship, and this is a very famous Zeppelin airship. People thought that this will be a new methods for air transportation, and people started using this for air transportation. But then suddenly one thing happened: a big Hindenburg disaster, very very famous disaster. There were some 97 people abroad, 36 passengers got killed. They used highly flammable hydrogen gas instead of safer helium. And this disaster itself, there was an end of airship. So they have not progressed further. Now let us talk about heavier than air. 17th and 18th century, lot of work. 19th centuries, and some of the famous pioneers, Sir George Cayley, Langley, and Wright brothers. I think it has gone to some. Oh, is it still visible?
Yes, sir.
All right, all right. I have clicked somewhere, so probably. All right. We'll skip this. So these are the famous, very, very famous pioneers. I'm not going to read everything. Sir George Cayley is given a name Sir. You can see his contribution. The first modern aircraft, he was called the father of airplane in 1846. He laid down the basic principles of heavier than air flight. minute, I'm getting stuck up here. Why? Yeah, so yeah, all right. Okay, so heavier than air flight, and he was the first person to say that there are four forces acting on an aircraft: thrust, lift, drag, and weight. Okay, and he also gave the concept, contributed towards understanding ornithopters and parachutes. So this is a paper by him, long back in one of the journals, 1852. Otto Lilienthal was another very famous person who led to the design of gliders. He was known as Glider King or Flying Man of Germany. So 1895, you can see him flying one of the gliders. He made over 2,000 glides until his death from injuries sustained in a glider crash. He died. He had a 2,000 glides. Unfortunately, one of the glide flight, he he got injuries and subsequently he died. Samuel Langley, another famous pioneer, he started serious investigation into aerodynamics. He did a lot of experiments in aerodynamics and he made an aircraft called Aerodrome 5, made the first successful sustained flight of an unpiloted, these are all before uh, Wright brothers. Engine driven heavier than aircraft of substantial size, big size. So this was his aircraft known as Aerodrome number 5. Glenn Curtis, he made a lot of modification to the existing design. He worked along with him. And this is the aircraft Glenn Curtis he flown from 1878 to 1930. He made a lot of modification in the design. Now we come back to the first manned powered flight. First manned powered flight, historical event. Who were the people? Who were the people who made the first flight? Who invented aircraft? Any name? Who invented aircraft?
Right,
The
brother, sir.
Wright brothers. Very good. Wilbur Wright, and Orville Wright. So this was the very first flight. This is one of the brothers watching. Where is the other brother? Can you tell me? Where is the pilot here? The pilot is lying using both his hands. So this was his cockpit. You can just see that. It's very interesting. So anyhow, let me first complete. Wright brothers flew the first manned, powered, controlled, heavier than air flight. A historical landmark in aviation. Okay. See, the Wright brothers were designer, experimental people. They were also pilot. They were also test pilot. They were engineer. They were fabricator. They were uh, structural people. They were propulsion people, and they were post-flight analysis people. All in one. Can you imagine? And what kind of risk people will take? But today everybody is enjoying just because of their hard efforts. Orville Wright flew the Wright Flyer on 17th of December 1903. The first flight went up to 120 feet in 12-second flight. The fourth aircraft by Wilbur Wright crashed actually. Of course, he survived. Okay. So these two brothers, very interesting story. I have written a book on the story of Wright brothers. I'm going to soon release it in Amazon. Okay, very interesting. Who will fly first? Okay, they had a toss, and in the toss, one of them got it chance for the first flight, and their father put a condition: both of you will never fly together. Only one person will fly at a time. Okay, only once in their lifetime it so happened that both of them flown together. So world aviation, the principal flight, having understood, we'll try to understand the principle of flights, how it flies. How many of you have some aerospace background? Doesn't matter. Even if you don't know, we will try to understand the basics of flight. See, these are the parts of an aircraft. This is called fuselage. I hope my pointer is seen. This is called wings.
Yes.
Fuselage means basically all passengers, cargo will be there inside. These are the wings, and wings are mainly responsible for generating lift. Lift means is a force, vertical force upward, which has to balance the weight of the aircraft. Huge weight. This is called the tail. Tail is responsible to provide stability and control to the flight vehicle, to the aircraft, and these are the engines which which provide propulsive thrust, which provides forward motion to the aircraft. Because of the motion of the aircraft retains a velocity. Because of velocity, the aircraft will generate a lift. We will understand. In detail, these are the various parts. Okay, this is available in this thing. Interested people can go through. Now, how does an aircraft fly? As I told you, as the aircraft fly, part of the wind, okay, it will go on the top, part will go from the bottom. This is the airfoil. This is airfoil. Airfoil is nothing but a cross section of the wing. If you cut it and look it from the side, that is called an airfoil. So some airstream will go from the top, some will go from the bottom, and then there are certain principle, continuity equation, Bernoulli's principle, Newton's third law of motion. Put together, it will so happen that the velocity on the top will be high, leading to the low pressure on the top, and the velocity on the bottom surface will be low, leading to high pressure. Now the pressure on the bottom is more, pressure on the top is less, so there is a differential pressure acting upward. Pressure multiplied by this area will give you the force, which is nothing but the lift force. Okay. So this is simple basic principle, Bernoulli's principle. When the velocity increases, because P plus half rho v square has to be constant. If velocity increases, pressure will decrease. If velocity decreases, pressure will increase. So it's a simple principle. Because of this, the aircraft will fly. So these are the forces acting on an aircraft in a straight and level flight. The lift, which balances the weight, and thrust balances the drag. Lift is equal to half rho v square and drag is equal to half rho v square S series. This is a formula, function of velocity, air density, wing area, and the characteristics of the design, CL and CD. CL is the lift coefficient, CD is the drag coefficient. This is a function of so many parameters, basically the design aspects. So these are the drag forces. Just see the drag will be very, very high. If this, that's how we have to design like aerofoil shape. You see, if it's a rectangular, circular, or aerofoil shape, how the drag has been drastically reduced. If you reduce the drag, the power required by the engine will be reduced. So you require less fuel. So drag is a very, very important parameter in aircraft or any space vehicle. Our tendency drag should be as low as possible so that our fuel requirement is also as low as possible. This is the angle of attack. Angle of attack means with respect to airstream, how it is lift will increase. But up to certain angle of attack. If you further increase the angle of attack, there will be a lot of flow separation and lift will further reduce. So this is called the maximum angle of attack is called the stall angle of attack. Stalling, this is called stalling. That means the aircraft can fly up to a minimum velocity to sustain its flight. If the velocity is less than stalling velocity, aircraft is no longer an aircraft. It is a body. It will just simply fall down. Now these are the control surfaces. The tail portion provides stability and control. These are called elevators. Elevators are going to make upward and downward motion of the aircraft, basically to give a steering action. Ailerons are for rolling. One wing will go down, one will go up, and rudder is for yawing motion. That means aircraft to turn left and right. Okay, so these things will steer the aircraft in the desired direction, like you are steering your car or scooter, because you are doing only a two-dimensional motion, but in the aircraft, it is a three-dimensional motion. So this is your pitch. Just see the elevator has been deflected and the aircraft is tilting upward. This is your aileron. One will go up, one will go down, and it will give a banking. This is called banking or rolling. This is yaw, where the rudder will deflect and the aircraft will go turn towards right side or towards left side. Before we go further, try to understand Mach number. Mach number is nothing but velocity of the aircraft to the speed of sound. Is the ratio. It's a dimensional number, and it Mach number means it is honoring a scientist, Ernest Mach. All right. So there is a subsonic flow where the Mach number is less than 1 everywhere. Transonic flow where the Mach number is between 1 and 1. Normally we say 0.8 to 1.2. So this is subsonic Mach number. Very smooth flow. This is transonic Mach number. There will be formation of shock. So because of time constraint, I can't speak more about that. This is supersonic flow and this is hypersonic flow. Supersonic flow is I think it has not come. Supersonic flow is between Mach number more than 1.2 and less than 5, and hypersonic Mach number we call as more than 5. And hypersonic flow is very very interesting flow, very very challenging flow, and where all the people in the world are working towards hypersonic. The future is hypersonic technology. India is also working quite a lot on this, but there are certain challenges because the major challenge is that the temperature, heating, severe aerothermal environment during its flight. Then power plant, there are variety of power plant, right from IC engines, jet engines, and today state of the art scram jet engine using the hypersonic missiles. So this is the evolution. The piston engine 12 horsepower were used in Wright Brothers flyer. Then slowly coming to the piston to turboprop engine. These are the jet engines. Today all passenger aircraft are using these jet engines. Of course there are variety turbojet, turbofan, variety of the things. Then comes futuristic ramjet engines. Okay, then scramjet engine. This is the scramjet engine. The beauty is that this engine is no rotating. Hey, a lot of rotating parts are there. Turbine and compressor, they are rotating at a very high speed. But in ramjet and scramjet, there are no rotating parts. But the problem is these engines cannot start from static. That means from beginning. They can start. They can't start from zero. They require an initial velocity. Okay, then only you can switch on to this. So there are advantage and disadvantage. But as we want to increase speed, more and more speed, we have to use ramjet and scramjet. So these are the turbojet engine. You can see a lot of rotating parts. This is the scramjet engine, no rotating parts, simple duct, but very efficient at hypersonic speeds. But they can't operate at zero speed. The scramjet propulsion system is the only option for hypersonic travel, and scramjet is the key for future of aerospace. Having understood all the things, so today state of the art aircraft, variety of the aircraft, passenger, helicopter, fighters has been developed by people all over the world and have been flying. Now the types of the aircraft are heavier, lighter than air. I already told you, and heavier than air. Again, they can be with engine and without engines. If they are with engine, they can be fixed wing aircraft. Again, land based, a typical turbojet engines, water based, then rotary wing aircraft, helicopter and gyroplanes, and without engine. We call it gliders and kite. So civil aircraft, they can be fighter aircraft. The types of the wing can be straight wing, swept wing, forward swept wing, oblique wing. So variety of designs are possible depending upon the specification. People are designing the aircraft. Similarly, types of wings: biplane, single plane, variable sweepback, delta wing, triplane. Okay, you can have anything. Similarly, types of tail, you can just see this is a high T tail, just see it's a blended tail. Okay, so different types of tail are possible. Engine arrangements you can have on the wings, you can have on the top here, you can have like this. Okay, you can have on the top of the wing. So variety of ways are there to put engine also. Similarly, helicopters, single rotor, double rotor, tandem rotors, a variety of helicopters are there. Similarly, there are unmanned air vehicles and unmanned combat air vehicles. Okay, you know all those things. So today UAVs and drone, we call it drone. They are now buzzword. Everybody talking about. All startups are working. A lot of startups working on drones and related technologies. So this is the ultimate UCAV. You just see the Hellfire missile integrated to it. It has been used in combat number of times. So these are some of the first transatlantic flight. Lindenberg, the Spirit of St. Louis is a very famous aircraft which has flown 1927, covered from New York to Paris. Okay, it was the first flight long back. World's first airmail was in India, Allahabad to Naini. 30 minutes flight carried about 6,500 letters. First supersonic flight by Chuck Yeager. See, in 44 years, 47 to 1903 was the first flight. It took almost 44 years to break the sound barrier. People were very scared. What is sound barrier? Sound barrier means you can't cross the speed of sound. That means transonic Mach number. So this person, brave enough, took the decision, I will fly it. So his friend suggested, your bones will break because so much a load will come. But somehow he successfully flown in 1947. Then only it became possible for further flight, supersonic and hypersonic. Until unless you cross sound barrier, you can't think of supersonic and hypersonic. Non-stop round the world flight, 1986 Voyager. There are many more. I have skipped it. Come to the rockets and missiles. This is a very famous hero of Alexandria principle where the steam is going and it is rotating. Okay, so this showed that action reaction principle. This was the basic principle on for rocket. Chinese rocket invention of gunpowder led to the development of first rocket by the Chinese in 1969. This was the first rocket made by China, and this was the gunpowder. So this is considered the first rocket engine to leave the ground. Okay, then a bamboo stick was attached to provide the stability. Of course, we all know Newton, his laws of motions, they are the basic behind rocket motion, action and reaction. Rocket motor basically burns the propellants and all these high speed gases are exhausted through the nozzle. Because of action, there will be reaction and the rocket will move forward. It's a simple basic principle. Okay, you all know that basically. This and Goddard is a very famous aircraft, famous rocket engine, liquid rocket engine, and these were the pioneers. This is like a balancing. If you just release this thing, the air will be going outside and this fellow will go backside. So same principle is in rocket. These are the pioneers. Sholkovsky, Russian person, he made a famous equation. Robert Goddard, von Braun, and in Indian Vikram Sarabhai. See, the World War came, World War One and World War Two. They found out the bad aspects of using, aerospace technology, aviation technology. The flying bomb was made V1. This was buzz bomb called also buzz bomb. This was the first cruise missile in 1944. The very first cruise missile was V1. And similarly, V2 missile, it was basically liquid propulsion rocket motor. And this was the world's first operational ballistic missile in 1944. Okay, so these things were very terrifying. The enemy thought that they are, they never expected that some coming at hypersonic speed and this was the first body to experience hypersonic flight. Okay, so this has caused no terrorizing effect. But the thing is that before flying, because the quality control was not that good at that time. Then came space. The very first Sputnik launched in 1957. Yuri Gagarin, the first person to go to space in this vehicle was 1961. Then there was a cold war between Russia and then American also started 1958. Just a few days after, they also sent that Explorer 1 and the X-50 experimental flight. This also has flown to the edge of the space. Edge of the space means there is a fictitious line called as Kármán line, which distinguish between atmosphere and space. All right, space means we say it's a total vacuum. Altitude. So they have developed so many things. Apollo 11 transportation system or shuttle. So several countries and agencies, more European space agencies, France, Japan, Israel, and India started developing their own launch vehicles. These are today, as on today, these are some of the most powerful rockets in the world. LVM-3 is our Indian, known as Bahubali by ISRO. Okay, so these are various rockets developed by different people in the world. Man in space, Yuri Gagarin in Vostok, and Alan Shepard from US. Okay, so he has gone in this vehicle, he has gone in this Vostok vehicle. Similarly, women, the first person to go to space, Valentina Tereshkova. This is the who went American woman, and first space mission, Kalpana Chawla, first space mission, is a Indian born scientist. Okay, she was my senior in Punjab College, Chandigarh, and a good friend of mine. During the moon mission, the Saturn V was a very famous rocket. It was used for the moon mission, and Neil Armstrong and his team in Apollo 11, they were the first person to go to the moon and experiencing hypersonic flight. Space shuttle also could carry up to 6 astronauts at a time. Long space shuttle mission 81 to 2011, and now this thing is now a mission is closed, and some of the orbiters were lost during accidents. And in one of the accident, we lost Kalpana Chawla. ISS International Space Station, also by Indian American, it provides a platform to conduct scientific research, etc. All of you know it is very low orbit. Similarly, rocket Sarvadhaya, known as the father of the Indian space program, and starting from three, then PSLV, and today ISRO is one of the agencies in the world made after successful completion of Chandrayaan mission. Okay, and these are various launch vehicles by ISRO. Now, rocket has two major aspects. One is space vehicle, all space missions, rockets, sounding rockets, expander. Also, there is another aspect called as weapons, size, static missile, space size. In 1972, the world's first missile was from India. 1792. 1899. These were the Tipu's rocket, considered the world's first missile. Rocket, iron tube, and Dr. Kalam in his book Wings of many these aspects in his book. Rocket vehicle which world actually has their roots in India. So it took almost 190 years to launch its missile. 25th of February 1988, India launches its first missile, Prithvi, and followed by Agni 1989. Tell me when okay.
Sir, are you ready?
Yeah, I'm hearing you. Any problem?
Go ahead, sir. Yes, sir.
No, are you able to see it or no?
Um,
Are you able
there's
to see
some.
my transparencies slides?
No,
Please
sir.
tell me.
No,
Shall I
sir.
start again? I'll
Yes, sir.
rejoin. Okay.
Yeah, yes, sir.
Uh, but I can see you.
We cannot see your video, sir.
Oh, video is switched off by default. I don't know. Now?
Yes, sir.
Okay, okay.
You can
Is
continue, sir.
okay?
Yes, sir.
Right, right. So a stone is a missile, bow and arrow, these are all missiles basically. The idea is to hit a target, to damage a target. All right. So there are a variety of missile, air to air missile, surface to air missile, air to surface, surface to surface, surface to underwater, anti-tank missile, anti-aircraft missile. So variety of missiles are there depending on their functions.
Sir,
So there are two
sorry
types
to
of missile,
interrupt.
strategic missile.
We cannot see your
Please
screen,
tell
sir.
me. Okay. Just 1 minute. Let me see whether this is available in. I will share it again.
Yes, sir.
Now,
Yes, sir. We can see the screen. So
all right.
5 more
So
minutes, then we'll start the Q&A session.
speak again.
5 more minutes, sir. Then we'll start the Q&A
Okay,
session.
okay. So I'll go
Yes.
very quickly. So strategic
Yes, sir.
missile and tactical missile, ballistic, cruise missile. So variety of missiles are there. All right. So strategic missile basically a very big missile. Tactical missiles are normally smaller size but very highly maneuverable missile. Okay, and then cruise missile mostly they use air breathing engines. That means within the atmosphere, they will be within the atmosphere. This success story start India today. India is really a leading country in the world, having mastered the technology, missile technology, and various missile system. Future of aerospace. See, we started with Wright brothers, then breaking the sound wave, supersonic flight, first hypersonic first vehicle to experience hypersonic flight, Yuri Gagarin, moon mission, space shuttle, and state-of-the-art scramjet hypersonic, and it will continue basically. So faster air transportation. We made Concorde and TU. Somehow they were not successful. Yet people are planning futuristic hypersonic airplanes. So these are the concept airplane people are planning. Hypersonic flight is today the buzz is a very important thing people are thinking today. Okay, so they can fly very fast. Just an airplane will take about 14 hours, but a hypersonic flight will just take about 2 hours to go to about 14,000 kilometers. They will fly almost Mach 6. So these are the historic review. We already discussed these things. Okay, in towards hypersonic. Also, there are concepts called a turbine-based combined cycle. Okay, where turbine engine and rocket will be used. Similarly, rocket-based combined engines. See that nothing is perfect. Turbojet is good at the low speed. Ramjet is good at about Mach 2 to 4. Then scramjet is good. Can be combined all those things. And rocket, why we should fly from the ground? Because it consumes a lot of propellant. It wastes lots of propellant. Okay, its payload fraction is very, very poor. So can we combine in such a way that it can be optimized? So people are thinking in the futuristic. See, these are things. Okay, like turbojets are very efficient, the low speed, then ramjet, then no, then turbojet, ramjet, then scramjet, and then rockets. Rockets can be at very high speed. So can we use turbojet to ramjet, ramjet to scramjet, air breathing to rocket? Can we switch on the roles during transition? So these are the people thinking of it in the future, and these are some of the futuristic concepts. So futuristic concept, we are thinking of nuclear thermal propulsion. People are thinking electromagnetic launch systems. These are all future. Space elevator. Just see, this is our can it's just like some sort of cord, some sort of wire. You can just go like a lift. Simply go to the whatever weight you want, whatever the height you want. This is geostationary orbit around 36,000 kilometer altitude. Okay, these are the proposals. Okay, these are all crazy ideas, but somehow they may get this thing. So this is the idea of a space elevator. these are futuristic things. So Indian aerospace, there are lots of opportunities. And today, Indian aerospace industry is one of the fastest growing sector in the world. India is soon expected to become the third largest aerospace industry. So I'm just telling you as a students, opportunity in aerospace. Okay, so there are various agencies, DRDO, ISRO, HAL, NAL, Civil Aviation, and various startups. A lot of people are working now on aerospace, and there are a lot of private sectors are now coming into this field. So there are opportunities in aviation, academia, startups, aircraft, missiles, space technologies. So phenomenal growth of the sector is poised to offer a galore of lucrative opportunities. So there are various startups, Agnikul, Skyroot. You can just see there's so many startups are there basically, and these are the various their products basically. So these are the opportunities in aviation industry, space sector, tourism, defense sector, unmanned air vehicle, aircraft industries. So these are the various carriers. People can think of it. And with that, I close my talk. It is a very, very generic talk. And I wish all students a bright and prosperous launch in your career. Thank you.
So that was really a great session. We would want to have one more session soon. And thank you for joining in such a short notice. That was truly an inspiring session. Thank you so much, sir. Hope everyone got to learn something new from today's session. Friends, now it's your turn. Please drop your questions in the chat box. Keep them short, clear,
Who
and
is
relevant.
speaking? Who is speaking?
I am Saharsha, sir.
Where the where the chat box?
I'll ask the question, sir. Sir, we have a first question. So can you kindly stop presenting
No,
so
I'm
that
not
I
able
can
to
ask?
know who is speaking.
No,
Okay,
sir. I'm gonna ask you
one
the
minute. I
question
can
from
stop.
the
I can
chat
stop
box.
sharing, right?
Yes, sir.
What do you want actually? Tell me what you want.
Sir,
I have not understood. Huh? Please ask.
sir, we have first question.
Yeah, ask the question. What I should stop? Huh?
What are some of the DRDO's most successful projects? It's a question from Jayant.
The most successful. The most successful is IGMD program itself, where we started with 5 simultaneous projects. And the idea was there are variety. There are different technologies, totally different technologies, so that we could understand so many technology we can develop. See, when we started, okay, when I started, basically I was also part of DRDO. Nothing was available. Most of things were not available. We almost started from scratch. Okay, so once you have done that, lot of technology was understood, and which had laid the foundation for further development, basically. Okay,
Sir,
Agni is the most successful. Prithvi, Akash, and you can see the role of Akash in our Operation Sindoor, and then BrahMos. They are all now state-of-the-art missiles. Astra, air-to-air missile Astra, hypersonic programs, all are doing well.
sir, can you kindly stop sharing the screen?
Stop sharing.
Yes, sir.
Please tell me, I'm not understanding you. What you are saying?
Can you please stop the screen, sir? The
Please speak.
sharing screen.
Oh, how do I stop the screen?
There is a stop button there,
Where is
sir.
the stop?
Stop screen.
Stop presenting.
Yes, sir.
Stop presenting, right?
Yes, sir.
Okay.
Yeah.
Now is okay?
Yes, sir. So we
Right,
have
right.
a
All
second
right.
question from one of our coordinator. Siri, please go ahead.
Hmm.
Thank you, Saharsha. Good evening, sir. I'm Siri, BTech graduated in aeronautical engineering. I'm honored to ask you this question. What do you consider the most challenging unsolved aerodynamic problems in modern defense aircraft and hypersonic vehicle design?
Yeah, there are a lot of problems actually. Aerodynamics problem is, see, in hypersonic or aerodynamics means basically the problem is boundary layer transition. Okay. See, you have to understand the behavior of the boundary layer, how it Okay, so it's very difficult to predict it. People are working on that, and also there are ways how do we compute it, because nowadays CFD is there, people are using computation fluid dynamics, but they have their own problems. Okay, until as we go with very advanced numerical technique like direct numerical simulation, but they will have a lot of computational power requirements. Still we are developing now because computer power is increasing, and people have now started working on it. So that is one thing. Then the thing is that basically aerodynamic and hypersonic, the heating address, the temperature are enormous, enormous temperature. Okay, no material will withstand. You have to have special material like composite materials, carbon, carbon, etc. All right. So there are many problems in aerodynamics to be solved, and basically all hypersonic programs have to be integrated design, blended design, where propulsion and aerodynamics have to complement each other. Okay, stability and control, because the speed is so high, the dynamic response has to be very, very good, extremely good, right? You deflate the control surface, should immediately respond at such a tremendous speed. You can't afford to miss your targets basically. Is it okay?
Yes, sir.
Experimental is a problem, but fortunately now we have got some hypersonic wind tunnel in India. We have got two wind tunnels, one by DRDO and one by ISRO. So probably you can use that now for more experimental investigation to understand the various behaviors.
Thank you, sir.
So we have a next question. What is one of the that mechanical engineering students should focus on to get into aerospace and defense manufacturing sectors?
See, there are two things in all aerospace vehicle. Any aerospace vehicle, the most important thing is quality and reliability. Okay, you can't be you can't. It's very, very important basically. Okay, so mechanical person who are good in integration. Integration is one of the aspect. The way the mechanical integration required precision workshop, precision manufacturing, and nowadays they are called that what is it called mm, uh, you know uh, some, okay, I'm forgetting it, but doesn't matter. But quality and control is very, very important, and there are now fabrication technologies, advanced fabrication technologies. All right, so they can focus on that.
Yes, sir. So next question. What is the difference between turbofan and turbojet engine?
See, turbojet and turbofan basically are nothing but uh, turbojet engine is basically where most of the air will go from the compressor. Turbofan, what they do, part of the air will be going around that. There is a passage after the engine, and there's a skin bit. It will be bypassing basically. It won't go from the central engine. It will bypass from the outside. Okay, and they will mix up at the later basically. Okay, so turbofan has got better efficiency than turbojet.
Yes, sir. So next question from Hasini. Sir, I am Hasini, a first year Tribly student. I dream of building rockets. As a first year student, how should I start? What are core subject technical skills and project to become rocket engineer from beginning? I should focus on.
But you have to be student, no? You are. I mean, if you are a
She's a
student,
first
if you
year
take
Tribly student, sir.
triple student, okay. But you have to go through that basic courses, whatever it is on the rocket and missile. DRDO is offering defense technology, MTech in defense technology in rockets and missiles. That's the best way. You can just attend little classes and understand the basic principles. If you want to go to ISRO type of things, are you planning to go to ISRO? I mean, you want to make your built first rocket. That's the question.
Yes, sir.
Hmm. You have to understand some of the basic principles. Principles of rocketry, principles of propulsion, little principle of aerodynamics. Okay, then the launch vehicle design considerations. And this launch vehicle are normally multi-staging. So why multi-staging required? So you may have to have number of propulsion stages. It depends upon your starting point, how long you want to go, what is the range of your rocket, all right, what is the objective of the rocket, right?
Yes, sir. Yes.
So accordingly, you have to design it. You can design. There's nothing. There is, it's easy, but you have to have some basic knowledge basically.
Okay. So last question.
You can make at home also. Now people are making, from water, just compress something, but they're very dangerous. We don't do at home. Tell me.
Yes. So
Yes.
one last question, sir. How was
Uh,
reusable rocket technology changed the future of space exploration?
yeah, this is a good question. See, people are working on reusable. Reusable missile means basically what happened. Okay, already people are working. Space shuttle also is a reusable vehicle. See, the cost of access to space is very, very high. Okay, what happened? A rocket, if it has to take a small satellite, a big rocket is required. It's called payload fraction. Mass of the payload divided by total mass of the vehicle, just 5%, 2%, 3%. Very, very expensive. In fact, Dr. APJ Abdul Kalam has given a lot of lectures. Okay, I had an opportunity of working with him very closely. He has given a lot of lectures where he was saying the cost of access to space has to be reduced by one order. If it is $1,000, it should cost $100. So, how to booster? You should be able to recover back. People are doing it now. Okay,
Yes, sir.
this Elon Musk, he also has done some experiments where they are recovering the booster. So, like that, you can reduce the cost of the access to the space. So,
Yes.
reusable vehicle, ISRO also launched one reusable vehicle, RLV, reusable launch vehicle. The idea is same. Okay, you can save a lot
Yes.
of money and you can do a lot of experiments basically.
Yes. So thank you for answering each and every question with such patience and clarity. Hope everyone has enjoyed today's session. To close today's session, I would like to invite one of the student coordinator to deliver a vote of thanks. Mr. Manish, over to you.
Thank you, Sahasra. Good evening, everyone. I'm Manish Kumar, Student Coordinator at KIYE Foundation. As we come to the end of today's Inspiring Stocks Lecture 14, on behalf of KIYE Foundation, I would like to express our heartfelt gratitude to our esteemed speaker, Dr. R.K. Sharma, former Director of DRDO. Sir, thank you for accepting our invitation and spending your valuable time with us. It was a great privilege to hear about your remarkable journey, your experience, and your contribution to the Indian defense and scientific research. Your inspirational words, practical insights, and valuable guidance has encouraged all of us, especially the students, to dream big, work hard, and contribute to the nation progress through science and technology. We are truly grateful for the patience and enthusiasm with which you all answered every question. Your thoughtful response made today's session more interactive, informative, and enjoyable for everyone. We sincerely thank Dr. G. Satish Reddy Garu and Naresh Indian sir for their constant guidance, encouragement, and support in making his talks a successful platform for students to learn from eminent personalities. I would also like to thank our coordinators, voluntary, and technical team, participants, and audience members. Your hard work, dedication, and active participation made today's event a grand success. Programs like S-Talks inspire young minds to explore new technology, new idea, develop innovative thinking, and build meaningful career in science, engineering, research, and technology. We hope to continue organizing many more such inspiring sessions in the future. Once again, thank you very much, Dr. R.K. Sharma sir, for being with us today and sharing your valuable knowledge and experience. We are truly honored by your presence. Thank you all for joining us today. Have a great evening ahead. Jai Hind.
Thank you, Manish, for your inspiring words. That brings us to the end of session of today's Talks Lecture 14. A few announcements before we leave. Do follow KIY Foundation on Instagram, YouTube, and LinkedIn. Share today's session with someone who would benefit from it. Stay tuned for updates on upcoming lectures and let's stay connected, stay curious, keep building. Thank you, everyone. Have a great evening ahead. Jai Hind.
Okay, thank you.